Okay, Chapter 8, we're going to look at the drill problems and the summary practice test at the end of the chapter. Remember that some of the values that we're using in each one of these questions may or may not match that of your textbook, especially since some of the questions at the end of the chapter in Connect are some of them can be static questions, but most of them are probably more of algorithmic. They change, but at least they are the same types of problems that you'll be working on. Beginning with the drill problems, let's go ahead and start calculating for it. And I'm just going to fill in the blanks based upon the question. And we have an iPad that costs $600. Okay, so I'm using the CMS, and this is a little worksheet that I have that's located inside of one of the handouts that's attached in your learning management system. And remember, in your formula, your cost plus your markup is equal to your selling price. The dollar amounts are to the right, and the percentages are to the left of the CMS. And so if I have an item that costs $600, and the percent of markup is 15%. I'm going to go to the left of the markup and then put 15%. And then the first few questions, it says assume that problems in numbers 1 through 6 are based on cost. If those particular problems are based on cost, I want to make cost 100%, which makes the cost the base. Okay, so base is $600, the cost of something. I have 3 items that I can work with, so I'm now ready to go ahead and work with the this particular problem since I have 3 items. And I'll use blue. I'm going to go to blue. I'm going to go to the first place I can add or take the difference. I can add the cost plus the markup percentages to give me 115%. And since that was the first place I went, I'm going to make that the rate. Since it's to the left of the CMS, and we'll go straight across and make that the part. Okay, that means I'm solving for the part, and remember the symbol that we used earlier that looks like this. The part is in the point, base is in the bottom, and the rate is in the right. If you're solving for the part, it's base times rate. If you're solving for the base, it's part divided by rate. If you're solving for the rate, it's part divided by base. So this one, I'm solving for the part, which is equal to the base times the rate. So that's 600 times 1.15 after I move the decimal point 2 places to the left. And that equals 600 times 1.15 equals $690. And then the difference between the cost and the selling price is how much it was marked up, which is only $90. And so I was able to find out several things on this particular problem. Number one, I know that we marked up the item $90 to sell it for $690, which is equal to a 15% markup based upon cost. Okay, number two. This is Burberry's men's watch, and it is $425 cost. And it has a 200% markup. And it's based on cost as well, so cost is 100%. And where the if the percent of markup is based on cost, and cost becomes the base. I have 3 items. I can go to the first place I can add or take the difference. So I'm going to add up the cost plus the markup percentages to give me 300%. I want to make that the rate. I want to go straight across, make this a part. Again, I'm solving for the part, which is equal to base times rate. So that's the same as 425 times 3, and that's going to equal 1275. And then the difference between the selling price and the cost is the markup amount of $850. Okay, the third one, the selling price is $6,000. Its selling price of office furniture at Staples is $6,000. Okay, the percent markup on cost is 40%. Since the percent markup's on cost, cost is 100%, so the cost is your base. I'm going to go to the first place I can add or take the difference. And I'm going to add up the cost plus the markup percentage to give me 140%. I'm going to make that the rate. Go straight across and make the selling price the part. And also keep in mind that the base is always associated with the, in this particular case, associated with the cost. So the base is on a row all by itself. The part and rate must be on the same row, whether it's above this point or below this point. So I'm going to solve for the base, and the base is equal to part divided by rate. So that's 6,000. Divided by 1.4 after I move the decimal point 2 places to the left, and that's going to give me 4285.71. Okay, the difference between 6,000, the selling price, and the cost of 4285.71 is 1714.29. Okay, so what I learned on this one is that my item costs $42.85.71 and I marked it up $17.14.29. My percent of markup based on cost is 40%. Okay, let's go ahead and take a look at the next question. We have the selling price of a home. Selling price of lumber at Home Depot is $4,000. And the percent of markup on cost is 30%. Since the percent of markup is based upon cost, cost is 100%, which makes cost the base. I'm going to go to the first place that I can add or take the difference. So I'm going to add 100 to 30, give me 130%. Make that the rate. Go straight across and make the selling price the part. So I have a value for the part, I have a value for the rate, but I don't have a value for the base. So in order to calculate for the base is equal to part divided by rate. I'm going to take 4,000 and divide that by 1.3 after I move the decimal point 2 places to the left, and that will equal 3076.92. Okay, then the difference between 4,000 and 3076.92 is 923.08. Okay, so what we've learned on this one is that the item cost $3076.92 and we marked it up $923.08 to sell it for $4,000, and this is based on a markup of 30% on cost. Okay, number 5. We have a cost of an item that's $15.10. And it's going to sell for $22. And we want to find the dollar markup and the percent of markup on cost. And this particular problem is the percent of markup is based on cost, so cost is 100%, and cost will be the base. I'm going to go to the first place that I can add or take a difference. And the difference between $15.10 and the selling price of $22 is $6.90. And I want to make that the part, since we're on the right-hand side of the CMS. Go straight across and make this the rate, since this is on the left-hand side of the CMS. And so we have a value for the part, a value for the base, but not one for the rate. So rate is equal to part divided by base. So 6.9 divided by the base of 1510 is equal to 0.456956. And if I'm basing this on rounding this to the nearest hundredth, that's going to come out to 45.70%. And then just fill in the blanks to complete the tic-tac-toe. 100 plus 45.70 is 145.70. What I've learned on this one is that we marked it up $6.90, which was 45.70% markup on cost. Alrighty, let's go ahead and take a look at number 6. And the dollar markup is $4.70. And the percent of markup on cost is 102.17. And the percent of markup on cost is 100%. So I'm going to make cost 100%, which makes cost the base. I'm going to go to the first place that I can add or take the difference. Okay, if I add 100 to 102.17, that's going to give me 202.17. I'll make that the rate since I'm on the left and go straight to the right. And this will be the part. Part and rate always go on the same row. Let's see, I've got a little bit of a problem right here because I have a value for the rate, but I don't have a value for the base, nor do I have a value for the part. I can't solve for both of them. So I can't move the base because the percent of markup is based on cost, so the cost is the base. I cannot move it, but I can move the part and the rate. So I'm going to mark out the rate right here, and I'm going to mark out the part, make this one the rate, and go straight across and make this one the part. Now I'm going to solve for the base. The base is equal to part divided by the rate, so I'm going to take 4.7 and divide that by 1.0217, which is after I move the decimal point 2 places to the left, and that's going to give me a base of $4.60. Okay, then just to add my markup to the cost of 4.7, that'll give me a total amount of $9.30. So in this particular problem, I marked it up $4.70, which is 102.17% of cost. That means that the cost of the item is $4.60 and I sold it for $9.30. Okay, now let's go ahead and take a look at number 7. Okay, number 7. Sony LCD TV has a selling price of $1,000. And the percent of markup is 45% on selling price. This is opposite of the first 6 problems. We always based it on cost earlier, which made cost 100% and the base. But since this percent of markup is based on selling price, I want to make selling price 100% and make the selling price the base. Okay, I'm going to go to the first place that I can add or take the difference. And the difference between the markup and the selling price is 55%. I'm going to make that the rate and go straight across and make this a part. So I have a value for the base, I have a value for the rate. I'm solving for the part, and the part is equal to the base times the rate. So 1,000 times 0.55 after I move the decimal point 2 places to the left is equal to $550. Then the difference between $1,000 and $550 is equal to $450. Okay, let's go ahead and take a look at the next one. Number 8 is the Canon scanner has a selling price of $80. And it has a markup percent of 30% on the selling price. So selling price is 100%, which makes the selling price the base. Okay, I'm going to go to the first place so I can add or take the difference. Remember, cost plus markup is equal to selling price. So something plus 30 equals 100, which is 70%. I want to make that the rate. Go straight across and make the cost the base. And so I have a value for the rate. I have a value for the selling price, which is a base. I'm solving for the part. Part is equal to base times rate. So 80 times 0.7 is $56. And then the difference between 56 and 80 is 24. So 56 plus 24 is equal to 80. So this particular problem is I have a $24 markup on a cost of 56 that's based upon a 30% markup on selling price. Okay, let's go ahead and take a look at number 9. Okay, number 9, selling price of a complete set of pots and pan at Walmart is what we're looking for, and it's 40% markup on selling price. So selling price is 100%, which makes selling price the base, and the actual cost is $66.50. We're going to go to the first place that we can add or take the difference. And the cost plus the markup is equal to selling price. That means 60% is the cost. That's the first place that we could go. So I'm going to make that the rate. Go straight across and make the cost the part. So we have a value for the rate. We have a value for the part. We need to calculate for the base. Therefore, the base is equal to part divided by the rate. So that's $66.50 divided by 0.6. After you move the decimal point 2 places to the left to give you 110.83. Okay, then the difference between the cost and the selling price is equal to $44.33. So we had a markup of $44.33 when the markup is 40% of the selling price, giving us a selling price of $110.83. Okay, then number 10. Selling price of a dining room set at Macy's is what we want to find. But that is a 55% markup on selling price. So we'll make selling price 100%, which makes selling price the base. Okay, I'm going to go to the first place I can add or take the difference. Oops, I need one more value, sorry. The actual cost of this item is $800. Need 3 things in order to play this tic-tac-toe. Now we're going to go to the first place that we can add or take the difference. And the difference between the markup and selling price is 45%. Let's see, let's change the color of the pen. Let's make that the rate since we're to the left and go straight across and make the costs a part. So we have a value for the part and one for the rate. We're solving for the base. The base is equal to part divided by rate, so that's 800 divided by 0.45 after I move the decimal point 2 places to the left to give me 1777.78. Okay, Okay, then the difference between 1777.78 and 800 is 977.78. So I marked up this item, $977, which is 55% markup based upon selling price, which makes the item $1,777.78. Okay, now let's go ahead and take a look at number 11. The cost of this item is $14.80. And the selling price is $49. And we want to find the percent of markup based upon selling price. So selling price is going to be 100%, which makes selling price the base. We're going to go to the first place that we can add or take the difference. And the difference between the cost and the selling price is $34.20. Let's make that the part since we're on the right and go straight to the left for the rate. And we have a value for the base and we have one for the part. So we can calculate this one for the rate. The rate is equal to part divided by base, which is 34.20, divided by 49 equals 0.6979591. And this one wants us to round to the nearest 10th percent. So whenever I do, that's going to make it 69.8%. And then the difference between 100% and 69.8% is equal to 30.2%, just to finish filling in the blanks, because cost plus markup is equal to selling price. I've determined from this problem that I've marked up my item $34.20, which is 69.8% markup based upon the selling price. Okay, now let's go ahead and take a look at the next question. And this item is number 12, and the dollar markup is $4. And the percent of markup on selling price is 20%. So make the markup 20%, and selling price is 100%. Since it's based upon selling price, which makes the selling price the base, I have three items now. And I'm going to go to the first place I can add or take the difference. And the difference between 20 and 100 is 80%, which makes that, since that was the first place I could go, I'm going to make that the rate. Go straight across and solve for the part. And I have a value for the rate. I don't have one for the part or the base, which means I'm going to leave the base exactly where it is. I'm not going to touch it because the base has to stay with 100%. So I'm going to move the rate and the part down one line. Now I have a value for the rate and the part, but I don't for the base, so that's what I'm going to solve for. Base is equal to part divided by the rate, which is 4 divided by 20, which equals base is equal to part divided by rate. Yeah, 4, I didn't do that right. 4 divided by 0.2 will give us $20. There we go. Will give us $20. And then the difference between the markup and the selling price is $16. What I learned from this is that we have an item that we purchased for $16 and we sold it for $20, which gave it a markup of $4, which is 20% markup of the selling price. Main thing is that you got to keep your part and your rate on the same row, and the base is always associated with the 100%, whether it be cost or selling price. Where the 100% is, that's where your base is going to be. Okay, now the next question is number 13. Okay, number 13 is a conversion problem. By conversion of the markup formula, solve the following and round to the nearest whole percent as needed. Okay, just to keep you in mind right here, I'm going to go back to a different sheet, but the cost plus the markup is equal to your selling price, and your selling price minus your markup is equal to your cost. So on this particular one, if we know the percent of markup on cost is 12.4%, oops, wrong place. Let me erase that. If I know that my percent of markup is 12.4%, and that's the percent markup based upon cost, I want to make cost 100%. Therefore, in purple, I'm going to add my cost plus my markup to equal my selling price of 112%. 112.4%. Okay. Then to determine what that same equivalent markup would be in selling price, I am going to divide there we go. 12.4% divided by 112.4%. I'm going to move the decimal point 2 places to the left to make it 0.124 divided by, move this one 2 places to the left to make it 1.124. Okay, so therefore the percent of markup on selling price, the equivalent markup, if it's 12.4% markup in cost, what is the equivalent markup in selling price? Let's calculate that. That's 0.124 divided by 1.124, and the equivalent markup would be 11%. Okay. The percent of markup on selling price is always less than the percent of markup on cost. Okay, now if we were looking at this going a different direction, let's kind of move this to the, I'll go to the side. Yeah, I can still see the side on this one. Again, cost plus markup is equal to selling price, or selling price minus markup is equal to cost. So I'm going to go backwards. I'm going to make this one 100%. And the percent of markup on selling price is 13%. And so I'm going to subtract the selling price from the markup to give me the cost, which is 87%. And now I'm going to take my original of 13%. I want to divide that by the calculation of subtracting 100 from 13 to give it 87%. That's my new calculation on this one. Then move the decimal point 2 places to the left on both of those. And so that's 0.13 divided by 0.87. So 0.13 divided by 0.87 is equal to rounding this to the nearest whole percent, which is 14.9% or 15%. So that's going to equal 15% for the nearest whole. Okay, so the percent of markup on selling price is 13%. Its equivalent percent of markup on cost is 15%. So this is a percent of markup on cost. This is the percent of markup on selling price. Remember, the percent of markup on selling price is always less that of the percent of markup on cost. Okay, so those are equivalents. Okay, let's go ahead and move to number 15. And on number 15, we're going to calculate the final selling price to the nearest cent and then mark down to the nearest hundredth percent. We have the original selling price of $5,000. We have the first markdown. We're going to do a markdown on this one. The first markdown is 20%. The second markdown is 10%. We never want to add these together, by the way. Then we have a markup of 12%. And then the third markdown, or the final markdown, of 5%. Okay. So we're going to start with $5,000, which is our selling price. And I could take it times 20% and find out the amount of the markdown, but I want to find out what the end result would be, what it would be after the markdown. So instead of taking it times 20%, I'm going to take it times 80%. Move the decimal point 2 places to the left. 5,000 times 80% is $4,000. Okay, then I'm going to take $4,000. And with the second markdown of 10%, instead of finding the markdown dollars, I'm going to find out the value of that. I'm going to take 4,000 times 0.9. And that will give you $3,600. And then I'm going to take $3,600. And I'm going to take that times 112%, or 1.12, after I move the decimal point 2 places to the left. And so I'm assuming that $3,600 is 100% of the value plus a 12% increase. So that's what made it 112%, or 1.112 after I move the decimal point 2 places to the left. And that will give me 4032. And then 4032 times the complement of 5%, which is 0.95 for the last markdown. And this will give me the final result of 38, 30, 40. Okay, so there's my final result right there. Okay, so it wants to know, calculate the final selling price to the nearest cent and then the markdown percent to the nearest hundredth percent. Okay, to find the nearest percent, that's rate, which is equal to part divided by base, and the part is the amount of the markdown. So the difference between 5,000 and 38, 30, 40 will give you 1169.60. So that's the amount of the markdowns and the markups. So I'm going to make that the part of 1169.60, and then divide that by the original base of $5,000, and that will equal the percent of all of your final markdowns and markups. So rate is equal to part divided by base. That's 1169.60 divided by 5,000, which is 0.23. 23.39% when you move the decimal point 2 places to the right. 23.39% increase after, or markdown, is the amount of the markdown that that one particular problem has. And then as we move down to the next one, number 16. Okay, number 16 is we have brownies. Okay, the brownies, we bought a total of 20. Okay, the unit cost is 79 cents each, and we want to find the total cost, and then the percent of markup on cost, is going to be 60%. And then we also want to find the total selling price. And then there's a percentage that will spoil. And that percentage is 10%. And we want to find the selling price per brownie. Okay, so all of those into consideration. We're going to start with trying to find out what the total cost is. So we have 20 of them, and each one of them costs 79 cents. So 20 times 79 cents is equal to $15.80. For the total cost. Okay, I'm going to go ahead and build my formula, CMS. And the cost is $15.80. And the percent of markup is 60% on cost. Since cost is what it's based upon, I'm going to make cost 100%, which makes cost the base. Okay, now I'm going to go to the first place that I can add or take the difference. And I can add the 100 to the 60 to give me 160%. I'll make that the rate, since that was the first place I could add or take the difference, and go straight across and make this a part. So I have a value for the rate and I have a value for the base. I'm looking for part. Part is equal to base times rate. So that's 1580 times 1.6. After you move the decimal point 2 places to the left, and that makes a selling price of $25.28. So actually we just marked that up by $9.48 for the entire batch that we produced. Okay, we're not quite done yet. We want to find out how much it's going to be per brownie. So if the total cost is $25.28, and it says 10% of our brownies spoiled. So how many brownies do we have left? We have 20, and if 10% of 20, which is 2, 10% of 20 is 2 brownies. That leaves us 18 brownies. We take the total cost divided by the total amount that we have after spoilage of 18, and that gives us $1.40 per brownie that we're going to charge. Okay, our next part is the break-even point. First, I need to find out what the contribution margin is, and the contribution margin that I want to calculate is your fixed costs less any variable costs that you might have. So it shows that a fixed cost is $65,000, and then the selling price per unit is $5, and the variable cost per unit is $1. So I'm going to subtract the variable cost from the selling price. $1 from $5 is $4. And I'm going to put $65,000, the fixed cost, on top. And so $65,000 divided by $4 equals the break-even point of 16,250 units. That means that once I found out my contribution margin, and my contribution margin is the it means that for, I don't know what the product of this one is, that for each one of the items that we sold, $4 goes to cover the fixed costs and results in a profit. It makes sense to cover the fixed costs first because the nature of the fixed cost is that it does not change with increases or decreases in sales. Then we take the final cost of $65,000 and divide that by 4 to give us the break-even point of 16,250 units, and that's just covering the cost. So each unit after 16,250 units starts to bring in a profit of the contribution factor of $4. Okay, that concludes the problems in numbers in the drill questions. Now let's scoot over to the summary test at the end of the chapter. Okay, number 1, Sunset Company marks up merchandise 40% on cost. Since it said on cost, I'm going to put 100% with the cost and make cost the base. A DVD player costs Sunset $90. Okay, so I have 3 items. Now I'm ready to actually play tic-tac-toe to calculate the final result. So I'm going to go to the first place I can add or take the difference. So 100 plus 40 is 140%. I want to make that the rate and go straight across, make this a part. Well, the part is equal to the base times the rate. So it's 90 times 1.4. And that equals $126. Okay, the markup amount is the difference between the cost and the selling price. The difference is $36. Okay, so what this tells us right here, it wants us to find the Sunset selling price of $126, which was 40% markup on cost. Okay, number 2. JCPenney sells jeans for $49.50. They cost $38. What is the percent of markup on cost? Since it says on cost, I'm going to make cost 100% and make cost the base. Round to the nearest hundredth percent. And to calculate this one, I want to go to the first place that I can add or take the difference. And the difference between the cost and the selling price of these jeans is $11.50. Okay, I'm going to make this a part since I'm on the right-hand side and go straight to the left and solve for the rate. The rate is equal to the part divided by the base. The part is $11.50 divided by the base of $38. Okay, $11.50 divided by 38 is equal to, let's see, round to the nearest hundredth percent is 30.26%. Then just fill in the blank. Makes that 130.26%. So the percent of markup based upon cost is 30.26%, and my markup was $11.50. Okay, let's move to number 3. Best Buy sells a flat screen high definition TV for $700. There's the selling price. Best Buy marks up the TV 45% on cost. That tells me that cost is 100% and cost is the base. What is the cost and dollar markup of the TV? I'm going to go to the first place I can add or take the difference. So I'm going to add 100 to 45 to give me 145%. To make that the rate on the left side, go straight across and make this a part. So I'm solving for the base. I have a value for both the part and rate. So the part is 700 divided by the rate of 1.45 after I move the decimal point 2 places to the left. That equals 482.76. Okay, now the difference between the cost and the selling price is $217.24. Okay, so what is the cost and dollar markup? The cost is $482.76 with a markup of $217.24, which represents 45% markup based upon cost. Okay, number 4. Sports Authority marks up New Balance sneakers $30. Okay, it says it marks up, so that's why I'm putting it here. We don't have many problems that start with that. And sells them for $109. Markup is on cost, so cost is 100%, which makes cost the base. Okay, I'm going to go to the first place I can add or take the difference. And the difference between the markup and the selling price is only $79. Okay, remember the rule is go to the first place that you can add or take the difference. Well, I'm already in the base right there, so now I can go to either one of these. Just as long as the base stays on the same row, I'm going to make this one the part and this one the rate, and the part and the rate have to stay on the same row. If I wanted to put part down here on this next row, I could, but just keep the rate on the same row that you use. So I have a value for the base and I have a value for the part. I'm solving for the rate. The rate is equal to part divided by base, which is 30 divided by the base is 79. And that equals, let's see, we are rounding to the nearest whole percent, so that's 37.97% after you move the decimal point 2 places to the right. And then just fill in the blanks. It gives it 137.97%. Okay, so our percent of markup based upon cost is 37.97%, which means our item costs $79 with markup at $30 and sold for $109. Okay, let's go ahead and take a look at number 5. The shoe outlet bought books for $60. There's the cost. And marks up the books 55% on selling price. So selling price is 100% this time, and the selling price becomes the base. Okay, we're going to go to the first place that we can add or take the difference. And the difference between 100 and 55 is the cost percentage of 45%. I want to make that the rate and go straight across and make this a part. And I'm solving, since I have a value for the part and the rate, I'm only looking for the base, and the base is equal to part divided by rate. So that's $60 divided by 0.45 after I move my decimal point 2 places to the left. And that gives us 13.33 cents. Oops, 133. 133.33. And the difference between the cost and the selling price is a difference of 73.33. Okay, number 6. Okay, Office Max sells a desk for $450 and marks up the desk 35% on selling price. Since it's on selling price, I'm going to make the selling price 100% and make selling price the base. Okay, I'm going to go to the first place I can add or take the difference. And the difference between the markup and the selling price is 65%. I'm going to make that the rate since I'm on the left and go straight across for the part. I have a value for the base, I have a value for the rate. So I'm solving for the part. Part is equal to base times rate. Base is 450 times the rate of 0.65. And that equals $292.50. Okay, the difference between the cost and the selling price is $157.50. Okay, so the percent of markup based on selling price is 35%, which means the cost of the item is $292.50 and it sells for $450, so we only marked it up $157.50. Okay, let's move on down to number 7. Okay, Zales sells diamonds for $1,100. That originally cost $800. What is Zales' percent markup on selling price? That's the question. What is the percent of markup on selling price? So selling price is 100%, which makes selling price the base. I want to go to the first place I can add or take the difference, and the difference between the cost and the selling price is $300. I want to make that the part since I'm on the right side, and I go straight left. This is on the left side, so that's the rate. I have a value for the base, and I have a value for the part. So I'm solving for rate, and rate is equal to part divided by base. It's 300 divided by the base of 1,100. And that equals, are we rounding to the nearest, to the nearest hundredth. So that's 27.27%. And then just to fill in the box, which we're not solving for because we already have our answers, but the difference between 100 and 27.27 is 72.73. So now to the left-hand side, your cost plus your markup percentages equals 100%. So now we know that we've marked up this item $300, which is 27.27% of your selling price. Now let's move to number 8. Earl Miller he's a customer of J. Crew, will pay $400 for a new jacket. This one's worded a little bit different. Let me read the whole question. J. Crew has a 60% markup on selling price. What is the most that J. Crew can pay for this particular jacket? So therefore, $400 is the selling price. And J. Crew has a 60% markup on selling price. So selling price is 100%, which makes selling price the base. We're going to go to the first place that we can add or take the difference. The difference between 60 and 100 is 40%. Okay, that one doesn't really read very well. Let me try a better color. Okay, 40%, and that'll be the rate. We'll go straight across and make this a part. We have a value for the rate and the base, so therefore we're solving for the part, and part is equal to base times rate. That's 400 times 0.4. That's going to give us $160 for the cost. And then the difference between the cost and the selling price is just to find the difference between the two of $240. Okay, so what we know about this particular problem is that the percent of markup was based on selling price, which is 60%, and the item cost $160. And we marked it up $240 to sell it for $400. Okay, let's go ahead and take a look at the next question. Number 9. Okay. Home Liquidators marks up merchandise 35% on cost. So cost is 100%, which will be the base. And what is the company's equivalent markup on selling price? Okay, I didn't read through the full question on this one, and we're going to round this to the nearest 10th percent. Okay, since cost plus markup is equal to selling price, let's go ahead and follow through with this. We're going to add cost plus markup, which is equal to 135%. And let me erase that. Can't tell the difference. Okay. Let's go with a green. Okay. So we're going to add this together, which is 135%. Okay. Since cost plus markup is equal to selling price, and we know that that originally it's 35% markup on cost, we're going to put 35 on top. And then we're going to add the cost plus the markup, 100 plus 35%, and that'll equal 135%. Then we're going to restate that, which is 35% over 135%. Then move the decimal point 2 places to the left to make it 0.35 divided by 1.35. Okay, now calculate 0.35 divided by 1.35 equals a percent of markup on selling price of, let's see, doing to the nearest 10th percent, which is 25.9%. So that's a percent of markup on selling price. So if you know the percent of markup on cost is 35%, then the percent of markup on selling price is 25.9%. Okay, number 10. The muffin shop makes no-fat blueberry muffins that cost 70 cents each. Okay, muffins. And let's see, we made 800 muffins. And they're 79 cents each. So our total cost is 800 times 79 cents each equals $632. It's the total cost. Okay. 632. Okay, the muffin shop, okay, it knows that 15% was spoil. We'll find that out in just a moment. If the muffin shop wants 40% markup on cost, so there's 40% right there. And since it's on cost, I'm going to make cost 100% and make cost the base. Okay, I'm going to go to the first place I can add or take the difference. So it's 140%. Make that the rate. Go straight across, and I'll be solving for the part since I already have a value for the base and the rate. So part is equal to base times rate. It's 632 times 1.4 after I move the decimal point 2 places to the left. That will equal $884.80. Okay, and then the markup is the difference between the cost and selling price of $252.80. Alrighty, let's see. Okay, where did I go wrong? Okay, let's see. 800. Okay. 40% markup, 140%. Okay. And the cost is 800 muffins. Oh, okay. Somehow I thought it was 79 cents. I misread that. It's 70 cents. Okay. It's 70 cents. And so that's where I went wrong right here. Let me correct those items. Okay, so the total cost is not 632. Let's do that part again. And 800 times 70 cents is equal to $560. Okay, now part is equal to base times rates. That's 560 times 1.4. That's $784. Okay, then the difference between the selling price and the cost is $224. And now, okay, good. Got this one worked out. And let's see. We have some spoilage. We had 800 that we originally made, and we had 15% spoilage. And so that is 1.5 or 1.5. 800 times 1.5. Excuse me, 0.15. 800 times 0.15 after you move the decimal point 2 places to the left equals 120. So that means we have 680 muffins left after spoilage. And it's $784 for the total amount, minus, or excuse me, divided by 680 muffins. And that should equal $1.15 for each muffin. Oh, got through that one barely. And then let's take a look at one more. And then I have a few more questions I want to add to this particular one. Angel Corporation produces calculators selling for $25.99. And its unit cost is $18.95. And we're assuming a fixed cost of $80,960. What is a break-even point in units? Okay, first of all, I want to find out what the contributing margin is. So I'm going to subtract the unit cost of $18.95 from the calculators that we're making for $25.99, the fixed cost of it, and that would give us $7.04. And then our fixed cost of $80,960, we'll calculate that to give us a break-even point. $80,960 divided by 7.04 will give us 11,500 units. Okay, so therefore, we must sell 11,500 units to cover the cost, and every unit sold after this break-even point generates a contributing margin of $7.04. For each calculator that we sell, 704 goes to cover the fixed costs and results in a profit. Okay, then I have a couple of other questions I want to ask in addition to some markdown types of problems. Okay, let's say that, put this one right here. Jane Jones sells bracelets. Priced at $200. On sale for $175. What is the percent of markdown? Okay, we're going to base this upon cost. We'll use a CMS formula. Cost is 100%, which makes cost the base. And it was originally priced, the cost was $200, and it was marked down to or sold for $175. Okay. The markdown, the difference between the cost and selling price, this time the cost is decreasing because we marked it down by $25. I'm going to make that the part, and then we'll solve for the rate. And the rate is equal to part divided by base. So the amount of markdown of $25 divided by the original cost of $200 will equal the percent of markdown. So 25 divided by 200 equals 0.125 or 12.5% whenever you move the decimal point 2 places to the right. So the percent of markdown was 12.5% or 12.5%. Okay, now let's look at another type of markdown problem. Maria Lopez bought a bracelet. Originally priced $500, and was reduced by 20%. What is the reduced price? Okay, we can do this one again as well. I don't really need to use a CMS on this one, but I'll go ahead and do it. Percent of markdown is going to be based on cost. And the item was originally $500. And then we are going to reduce it 20%. So I'm going to make the reduction 80%, make that the rate, and then I'm going to solve for the part. So part is equal to base times rate. And so that's 500 times 0.8. That equals $400. Okay, so originally cost $500 and or $500. I'm sorry, I can't read my writing. $500, and I marked it down 20% and sold it for $400. So basically what you're doing there is you're taking the original cost, $500, and then multiplying that times 20% to give you the markdown dollars. And it was, or not the markdown dollars, but the total amount. So you took the reciprocal of 20%, which is 80%, and that gives you the full value of what the reduced price is of $400. Okay, let's do one more. Oh, same problem. Pretty much. If Maria bought an item priced at $175 and is marked down 20%, what is the dollar amount of the markdown? Okay, this one, instead of taking it times the complement of 20%, we're just going to find out what 20% of $175 is. And so that's 175 times 0.2. And that's going to give you markdown dollars of $35. Okay, this concludes Chapter 8.